Now we have another numerical. You have to find out the inverse transformation of j d by d omega of e to the power j2 omega 1 plus j omega by 3. So basically, if I talk about the d by d omega of anything that is capital X of omega in frequency domain, that means there must be a multiplication of minus jt in the time domain. So let's say we have txt. So txt will have a Fourier transform of d by d omega x omega, or I can transfer this minus jt. So x of omega in this equation is your e to the power j2 omega divided by 1 plus j omega by 3. Or I can put this same equation 3 e to the power j2 omega divided by 3 plus j omega. So this is something like x omega is equals to j g omega e to the power j2 omega. So whenever there will be a multiplication of e to the power j2 omega, so that means the original function is being shifted by or delayed by an unit. If there will be a minus, so delayed. If there will be a plus, so advanced. So your gt will be 3 gt plus 2. And where g of omega is nothing but this is 1 by 3 plus j omega. And 1 by 3 plus j omega is nothing but this is something like e to the power minus 3 tut. So your gt will be e to the power minus 3 tut. And when you replace gt over here, so your final answer will be 3 t e to the power minus 3. Instead of t, I can put t plus 2 everywhere because of this e to the power j2 omega. So final answer will be x of t 3t e to the power minus 3t plus 2 ut plus 2. So this is basically the inverse Fourier transform of the given function. Now we have some numericals. Now the next important property is the convolution. Whenever you talk about the convolution in the time domain, so you have to use the integration. Something like if I want to convolve x1t with x2t, so I have to write minus infinite to infinite x of x1 of tau x2t minus tau dt. But whenever you take the transform of any convolution, so there will be a multiplication in the frequency domain. So convolution in the time domain results in the multiplication in frequency domain. So that is x1 omega into x2 omega. So suppose we want to convolute two signals, that is e to the power minus at ut, convolve with e to the power minus at ut. So we have the Fourier transform of the first function, that is 1 by a plus j omega. The Fourier transform of the second function, which is same, that is 1 by a plus j omega. So we know that the convolution of this e to the power minus ut with the same function is t e to the power minus at ut. So the final answer is 1 upon a plus j omega whole square after the multiplication of these two functions in the frequency domain. Now let's say if instead of having convolution of xt and ht, we have a convolution x alpha t with h alpha t. So your final answer will be 1 by mod of alpha y of alpha t. This is what I'm talking about, a LTI system. If it is being scaled by a factor of alpha. This is the thing that I already told you. Now, the important thing is frequency domain convolution. Frequency domain convolution is also known as modulation property, because what we are doing the multiplication of the two signal in the time domain, that is x1t multiplied with x2t will have a Fourier transform 1 by 2 alpha x1 omega convolve with x2 omega. And the last and the important property of the Fourier transform is the Pascal's theorem. Basically, the Pascal's theorem is used to calculate the overall average energy of a signal, which is minus infinite to infinite mod of xt square dt. And in time domain, you in time domain the frequency can be calculated, sorry, the energy can be calculated by this formula. Whereas if you have the Fourier transform of the signal, you will be easily able to calculate the energy of that signal, that is 1 by 2 pi minus infinite to infinite mod of x of omega square d omega. This is an important term that everybody has to remember, because this will help you to find out the energy of a signal even if you do not know about the signal. Once you know the Fourier series, Fourier coefficient, sorry, Fourier transform, you will be able to calculate the energy of the signal. Whereas in case of Fourier series coefficients, we actually calculate the overall average power of the signal. Now we have a numerical. It is given that capital A is real and non-negative, and F inverse means inverse Fourier transform of 1 plus j omega x omega equals to A e to the power minus 2t ut. And one more condition is given, that the overall energy of the signal is 2 pi. You have to find xt. Everybody should try. आपको xt निकालना है, दो कंडीशंस दी हुई हैं. Overall energy of the signal is given to you, and there is a relation of inverse Fourier transform of 1 plus j omega x omega is equals to A e to the power minus 2t ut. Find x of t. Yes, tell me, how will you proceed? Hello.
Yes, sir.
How will you proceed? कल आप लोगों का ऑनलाइन सेशनल होगा एक, ठीक है. वन ऑनलाइन सेशनल हैज ऑलरेडी बीन कंडक्टेड. Tomorrow there will be online sessional. So everybody has to present at your scheduled time. Please inform this thing to each and everybody. Late submission किसी का भी नहीं मांगूंगा, ना मैं accept करूंगा, and directly I'll give you 0. So make sure that everybody has to present on that time, and there will be online submission. I'll provide you the question one by one, and then you have to submit before the time. ओके, क्या करना पड़ेगा इसमें? बताओ भाई, बोलो फटाफट, इसको खत्म करना है आज मुझे, उसके बाद DTFT शुरू करेंगे।